Good evening, Zimbabwe. Good evening, Africa. Good evening, everyone. Welcome back. It's night, around past 9 in the evening. Yeah. It's Monday, so we've come for some few urgent jobs. Let me find out if I can see what I have to fix. Yeah, I have this laptop. It's a Lenovo model G40. The problem with this one, the customer said I was using it and just went off and I couldn't find what the problem is. So the charger is already plugged. See, USB type, ground plus. Let us see if our charger is working. Maybe we have a fault charger. $10 volts. No, our charger is not good. I don't think this charger is working properly. I can't see any voltage. But that's not the issue. I don't think that is the problem. Let me change this AC adapter. Let me try with another AC adapter. Minus plus. Check on the multimeter, 20.21 volts. So our charger is good. Let's plug our charger. Let's plug our charger. The middle pin is not at the center. Let's plug our charger. Our charger is plugged in. Here we must have a charging light, but we don't have anything. And if we try to power on our laptop, nothing happens. It's just dead. So let's open this one quickly. Let's take off the battery. Our battery is out. Let's take off all the screws and find out what's the problem. Maybe we can fix it. Maybe you can fix it. The problem with this type of laptops, G40, Lenovo G40, G50 series, the processor is soldered on the board. And if it happens that the processor is dead, I think that will be the end of the story. We are not doing reballing here of processors, and it's not worth it because people, they don't pay. Even if we buy reballing machine, that might not be helpful on this side because people, they are paying sick money. So if we check everything and we are satisfied that the processor is dead, that will be the end of everything. That's where we stop actually. Let's take off all the screws. Take off all the screws. Take all the screws out. Take the CD drive. That's the CD drive. I think on this one the keyboard is coming out, so let's try to take off the keyboard if we can. We have some clips. Take off all the clips. Let's disconnect. One is supposed to come out here. That's the switch connector, the touchpad connector. Still have more screws here. Yeah, we are inside our laptop. Inside our laptop. Let's take everything out. Let's take everything out. That's the screen connector. All what I want is the charging port and the motherboard. Yeah, that's the Wi-Fi card. I can see something here close to the BIOS battery. So what I want to do, let's first plug in our charger. Our charger is plugged. Let's check some voltages. I think that would be a good idea. 20 after the fuse, 20 volts on the input of the first MOSFET, 20 volts on the output, 20 on the input of the second MOSFET, 19 on the output, 2.5, 3 point something, 2 point something. Year 19. Let's go on any power supply. 2.3 point. So let's unplug the charger. Let's put it on output on the BP mode. Let's go after the second MOSFET and check if it's beeping to ground. We can see on our test meter, I'm checking the resistance of the output on the output of the second MOSFET to ground, and it's taking around 476 ohms, which is okay. According to the multimeter, we don't have short on the second MOSFET. Let's come with our power supply, because you can see with the power supply you can see many things. It's not enough just to check with the multimeter. I'm curious to see what kind of current is being drawn after the second MOSFET. 0.74. 0.74. Where's my microcontroller? Let's take this black thing out. Take this out. Let's inject voltage. It's taking some current. Although the current is too low, I just bent my finger. Let's test again. Let's test again. That's so interesting. You can see at this point that is the main reason why usually I don't put my trust 100% on the test meter. Checking with the test meter on the second MOSFET to ground, there's no short. But if I come with my DC power supply, 19 volts, around 2.8 amps, if we come on the second MOSFET, you can see on my switching power supply is taking 177 milliamps. That's not good for a motherboard which is not working. Why should something take current while this is off? So what does that mean? It means we have a short, but it's not a strong short, it's a partial short. So when I was checking with my hands, somewhere here, this chip is getting hot. So what I will do, just to see what's going on there, I'll use my alcohol. I'll use my alcohol. 1 second. I'll spray my alcohol on the affected area. I will inject my voltage, 19 volts. I want you just to see what's going on there. Look, the chip is drying quickly. If I put liquid on top and inject voltage, look, my chip is just dry. So we have a problem. Let's check something on those power supplies. We have coils. Zero zero. Yes, good. So this coil is shorted to ground. What I want to do more, let's jump with the voltage after the second MOSFET. Let's do it. Just to see what kind of fault do we have here. Just for you to see what kind of fault we have here. So what I want to do, I just want to short the second MOSFET. I will show you what I've done under microscope. I will show you 1 second. Let's find our nice bridge. Just a nice bridge. That won't fit the laptop, but we just want to see what kind of fault do we have. Let's do it. That should be okay. That should be okay. Let's go under microscope quickly and explain few things. So that's my charging port. Here we have a fuse. That's the plus of the charging port. After the plus, we do have a fuse here, and our fuse is good. After the fuse, we have our first MOSFET. On the input of the first MOSFET, we have 19 volts, and our 19 volts is passing through the second MOSFET, and from here, that's our second MOSFET. Here on the input, we do have voltage, but we don't have voltage on the output. So we just jump with the wire from the input to the output. And from there, we do have our 10 ohms current sensor, and from there, our voltage is going everywhere. So we just jump over the MOSFET, just to see if that will bring our 19 volts on all power supplies. So what I want to do now, I want to check for voltage. Voltage is not even detected. Let's come with the power supply. Ground plus and we have a problem. This chip is getting very hot, this one. I'm not sure whether this one is the 3.3 or 5 volts, but we can check. We can check. We can check to see what's going on here. Can check to see what's going on here. So we don't have voltage. When we jump through the first MOSFET, this chip is getting hot. So we can see we do have two coils here. So I can bet this one is the 3.3 and 5 volts power supply, and it's the new model where MOSFETs are inside of these drivers. So this chip is getting hot. So what I want to check next, here we do have the startup chip, that's our controller. So on our controller, yeah, that's the controller. These are the pins of the controller you are seeing, and here we have some capacitors, and on those capacitors we must have 3.3 volts. Checking here, you can hear the multimeter is beeping, and it's 0 ohms. On the other side it's 0. So clearly, let's go on other capacitors. 0 again. So clearly we do have a short. Our 3.3 is shorted, and that is the reason why we have short to ground after the second MOSFET. So what I want to do, let's come with 3.3 volts. Let's lower voltage in our power supply. 3.31, that should be okay. Let's go on those chips. Well, this is the new model. I can't see any BIOS chip here, but we can go on those capacitors. Our chip is not getting hot. Something else is getting hot. So what is getting hot here? What is taking 2.8 amps? You can see my board is warm here. I can feel the warm. The 2.8. Something must be very hot. Let's raise our current. 3.8. Let's raise our current. Okay, I will show you something again that's interesting. 0, 0, 0, I will show you something. I just need to check what kind of fault do we really have here. Yeah, our microcontroller is dead. On the main power rail, this chip, which I understand is providing 3.3 volts to the microcontroller, this chip is dead. And we have second problem, this chip is also dead. So we just want to have assurance how many faults do we have here. Check on test meter. What I'm doing right now, I'm trying to, here we have this output capacitor for the USB. So I'm checking where this plus or 5 volts is going, just to see where our 5 volts is located. We just want to locate our 5 volts power rail. If we see 5 volts, that should be also 3.3. That's a good idea to look for 3.3. Right. So if you come with our main power rail on the output of the second MOSFET, this chip is getting hot. This chip with the 3.3, that's the 3.3 volts power supply. This one and this one, that's my 5 volts power supply. You can see coil and chip and MOSFET are inside the chip. So our first problem, this chip is shorted on the main power rail. Secondly, what I did, I go on the microcontroller and check on these small caps around, which are located around the microcontroller. On these small caps, one cap should be connected to ground and the other one to 3.3. And if I check on all these capacitors, all of them, they are beeping, both sides they are beeping to ground. What does that mean? It means our 3.3 volts is also shorted. So if I come with my power supply to supply 3.3 volts on these caps, let's supply 3.3 volts. Let's do it. Let's supply 3.3 volts. We need some liquid here just to see what's going on. Let's see what's going on here. Maybe you can see it under a microscope. I don't know if you can see what I'm seeing. Maybe if we do it under a microscope, we can see something. Let's try to do it under a microscope, if you can. Let's try to do it. Put some alcohol on the chip. That's our chip. Check. I want you to check something. Check on the screen of my TV. I release 3.3, I inject 3.3, you can see. Soon as I inject 3.3, my liquid is disappearing. Check. If I release, liquid will come back together. Again, it will disappear. So what does that mean? It means our controller is dead. That's fault number 2. I don't know if you can fix this one. It's just damaged by high voltage. What I want to check first, we have all-in-one processor here. So what I want to check first, here we have our BIOS chip, but I don't think this BIOS chip has anything to do with this microcontroller. I think this BIOS chip is for the chipset inside this controller. So it's a good thing to check. Let's take off this heatsink quickly. Let's check this heatsink quickly. I just want to check what's going on there. Our 19 volts power rail is shorted, the 3.3 is shorted. Let's check this plastic thing. That's our processor there. It's all in one processor. So what I want to do, our test meter is still on diode mode. What I want to do, ground. I'll check on the pin number 4 of the BIOS chip. Pin number 4 is ground, so should beep to ground. You can see that's the pin number 4, which is normal I'll go on the last pin, which is our VCC pin. Pin number 8 should not be grounded. Check 0 0. We have a problem here. So on pin number 8, our pin number 8 should not be grounded, and it's grounded. So what I can do, because I'm not sure about this bias chip, whether it's a 1.8 bias chip or a 3.3, but I'll just lower voltage to 1.8. Should be okay. Just to see why on the last pin of the bias chip it's shorted to ground. Let's test. That's the last pin of the bias chip. Let's see where our current is going. Let's raise our current. Let's try to raise our current. What's going on with my test? Okay. Let's put our voltage. Yeah, that should be okay. What I want to do is to raise the current. Let's raise our current. Because that 3 point something is going somewhere. So I'm just curious to know where my power is going. Right. So let's clean our processor, because we have some heatsink compound there. What I want to do, you can even go under microscope again, just for you to see the kind of fault that we have on this motherboard. Let's go on the last pin. Let's inject some power. We are on the last pin of the VCC. Let's do it. Look, I released my probe for the 3.3 volts. Let's put it again on the VCC. Look what's going on here. We have a fault processor here. Check. Soon as I inject heat, voltage injected, see some bubbles, released, nothing. Voltage injection, some bubbles, released, nothing. We inject voltage, some bubbles, released, nothing. So surely our chipset inside the processor is dead. So we have 3 faults. So yeah, that's where I stop actually. That's where I will stop, because we can't fix everything. Many people, they think that when a device is dead, it must be fixed, which is not true. You can't fix everything. In this case, we have our chipset inside the controller is dead. Our microcontroller is shorted. The chip, which is supplying 3.3 volts, is also shorted. We have 3 faults. So we can't fix this one. Even if I send it to anyone, I don't think there's anyone who can fix this board. So you see how we diagnose things, from the charging port going to the main power rail to all power supplies. So it's unfortunate. That's a hard night Monday. We can't fix this one. See you on the next one. Thank you. Bye.